In race car engines, excess lubricating oil is stored in tanks rather than oil pans. This prevents the oil from sloshing around during the race and causing drag on the crankshaft. With less drag, performance is increased, so these oil tanks are part of a winning strategy. Race car oil tanks come in various shapes and sizes in order to fit into different vehicles. But their purpose is the same: to keep excess oil out of the engine to boost performance. Each tank starts with a computer design. The engineer maps out the precise dimensions. They input the measurements into computerized machining systems. This first one cuts a long piece of aluminum into smaller pieces, creating blanks to make parts known as tank rings. A vertical milling tool sculpts a recess in the blank to seat an O-ring sealer. Then, switching bits, the machine contours the outside of the blank, taking it from rectangular to round. Other tools carve a large hole in the center and profile the inner diameter so that the part will mate to the tank. This ring is designed to be removable to access the tank for maintenance. Here's the blank before and after machining. Like powerful cookie cutters, computerized punches cut out numerous parts from an aluminum sheet. They include the oil tank body, the top, and other assembly pieces. To make the tank body cylindrical, a worker turns a crank to curl it around a roller. This tank body is called the wrapper. He drills a hole in the bottom cone. The hole is for the line that returns lubricating oil to the race car engine. Using a thin bandsaw, he trims the cone to fit the tank ring. With a device known as a hydraulic tube bender, a worker shapes a piece of pipe to a precise radius. This pipe will be used to vent air into a chamber at the side of the oil tank. He trims the ends of the vent tube using a bandsaw. A worker welds the tank ring to the bottom cone, creating a thick seam all the way around. He then seals the seam of the cylindrical wrapper body and welds a top cap to a de-aerating baffle. Air will rise through it and vent it into and out of a side chamber, leaving only oil in the tank. He slides the baffle into the wrapper body. He inserts the vent tube in a hole on the side of the tank. He fits an adapter ring to the upper lip of the tank and taps it down with a rubber mallet. He welds the baffle and filler neck to the tank body, and then assembles the air vent chamber to the side of the oil tank and welds it to it. Moving to another station, a worker now taps perforated plastic inserts into holes in the air vent chamber. These inserts will both vent and filter the air from the tank. He fits a rubber sealing ring around the fill neck and screws the cap on. He applies adhesive back decals to the tank for branding purposes. He caps the oil inlet tube to keep contaminants out during shipping. He turns the tank upside down and installs a valve on the bottom of the vent tank. He inserts a rubber O-ring into a groove on the base of the tank wall and tucks it into place all the way around. After equipping the fittings on the cone with caps for shipping, he installs the cone on the base of the tank and screws the ring tightly to it. Accessing the tank for maintenance reasons will mean unscrewing this part. That completes this race car oil tank. Hooked up to a system of pumps, these tanks will receive and dispense oil sparingly to improve engine performance. They've been well equipped for life in the fast lane.